6. Chapter 10 is still focusing on inequalities. And we're seeing a lot of absolute values here. So I just want you, if you haven't watched the beginning of 10-5, 10-5 goes into an excellent detailed explanation of how graphing and how absolute values work with equations and inequalities. So I would advise you to, solving is okay, equals is fine. It's the inequalities where they get a little interesting. But we're going to have to graph this one. Before we didn't. So absolute value wants to know what value can be inside here that would come out to make 6. Well, we know that if this value equals 6, a 6 will come out, or if this value was -6, the absolute value would pop out a +6. So this is what we do, is we write two equations. We write 2y is equal to 6, and 2y can be equal to -6, because if that value inside there is -6, it will pop out a positive. So this is the technique that we do, is we write two equations and then solve for it. Y equals -3. So those are my two solutions, -3 and 3. Whoa, that's a bad 3. That is a real squiggly 3. So if we put in -3, we get -6. Absolute value of -6 is 6, hence why that's a solution. If we have to graph it, we write -3, 0, 3, and we put a dot above it, because there's only two solutions, so you would only see two dots representing the solutions. I don't know if we really need to graph the solutions when there's only two. Typically, we write a solution set. We're going to write two equations, 6y equals 24, and we're going to write 6y equals -24. Divide by 6, y equals 4. Divide by 6, y equals -4. So my solution is -4, 4. And if we had to graph those, -4, 0, 4. I like writing the dots above so we don't get any confusion on where they are and where they're moving, whether they're closed or open. Once you start graphing on this line, it gets very, very noisy. So Mr. McCausland will always graph his solutions above the number line. I'm trying to change the perspective of that across the math world. We'll see how I do. X equals 2, divide by 5, divide by 5, x equals -2. So my solutions are -2, 2. If we were going to write it in a solution set, we always write our solutions in numerical order. The number line looks like this, and then we have two dots over those two solutions, representing true values, or values that, when plugged in, would make a true statement. Just because it's division doesn't mean we change our technique. We are still going to write what's inside the absolute value, equaling the positive and negative value of that. We're going to multiply both sides by 3, because that's the inverse of dividing by 3. We get x equals 6. We'll write the inverse of dividing by 3, which is multiplying by 3. X equals -6. So we get -6 and 6. Technically, you could have also written plus or -6. That's a high school way of writing these two solutions. That means +6 and -6. When we have the plus and minus of a solution, we can write it using that symbol. We're going to put dots over it, and we're done. We get x over 2 equals 4. And x over 2 equals -4. We'll multiply both sides by 2. X equals 8. Multiply both sides by 2. We get x equals -8. -8, +8, -8, 0, 8. That was a bad There we go. Now we have multiple things, two-step equations. We still do the same thing. 2a minus 1 equals 5. 2a minus 1 can also equal negative 5. That value can simplify to negative 5, and it would still produce a true answer. 2a equals 6, divide by 2, divide by 2, a equals 3. Add 1, add 1, 2a equals negative 4, divide by 2, a equals negative 2. So my solutions are negative 2 and 3. We'll write negative 2, 0, and 3, and we'll put a dot above it. Equals, equations with absolute values are pretty straightforward. There's not too much. You should understand the concept of why we have to write two statements. That should be relatively simple to understand, that this can equal, it can simplify into negative 7, which would produce a positive 7. So that's why we're able to separate and write two statements, because we're writing each of the different possibilities. That's not 6. Possibilities that can be inside that would, when we take the absolute value, would produce a positive 7. 2x equals negative 8. Divide by 2. X equals negative 4. We get negative 4 and 3. So if we check that, negative 4, 2 times negative 4 is negative 8, plus 1 is negative 7. So we would get the absolute value of negative 7 inside here, hence where we get that. So we're saying this can equal negative 7. What value for x would produce negative 7? Well, negative 4 would produce if we simplify that left side. So that's exactly what's going on. And it's important that you understand how and what that means when I say that. 3x minus 1 equals 5. You can't just memorize the process of taking the positive and negative. You should also comprehend what this means, what we're doing, how we're manipulating the equation, and what that solution represents compared to the equation. Ooh, that's a fun one. Look at this one. So x equals negative 4/3. That is a solution. So negative 4/3. I don't have to write it as a mixed number. I can write it as an improper fraction. Hopefully your high school math teacher understands that and sees the importance or the validity, how that is a valid solution. You don't have to. Just like a decimal is an acceptable answer, a improper fraction should also be an acceptable. There's nothing improper about an improper fraction. It's just a different format. It is simplified. People will say, well, that's not simplified. It absolutely is simplified. If they say, well, you need to change it to negative 1 1/3, that's not simplifying. That is converting. That's converting it to a different format. And all three formats are acceptable. In fact, you'll find in most math books, high school math books, you will find that most fractions will be improper. That they will not convert it to a mixed number. Let's add 1. X over 2 equals 4. Multiply both sides by 2. X equals 8. Add 1, add 1. X over 2 equals negative 2. X equals negative 4. So my solution set is negative 4 and 8. We'll do negative 4. We'll do 0. We'll do 8 dot above it. Maybe Mr. Max should go on a road show. Here's that inequality. So very important. We need to remember that greater than or equal to is going to be or. We need to remember that less than or equal to is and. This is at least one true, at least one true, and this must be two trues. True, true. Okay, so if you want to see a little bit more of an explanation, you can go back to video chapter 10.5. So let's write these two statements. We still, again, are going to write two statements, the positive and negative of that, because 2y minus 1 is less than or equal to 5. Now that's less than, so we have an and statement. 2y minus 1 is greater than or equal to negative 5. Okay, so remember this is going to be an intersection. So we'll add 1, 2y is less than or equal to 6, divide by 2, y is less than or equal to 3, add 1, 2y is greater than or equal to negative 4, divide by 2, y is greater than or equal to negative 2. I like to sketch the solutions before I do my final solution. So you'll see me do a sketch graph with the borders, and then I will highlight and I'll go, let's sketch that in green, that in blue, and let's see where the intersection is. So y is less than or equal to 3. That's a closed circle going to the left. This is y is greater than or equal to negative 2. That's a closed circle going this direction. So since it's an and, I need true, true. That's one true. Right here is two trues throughout here, two trues on this border, and then we go back to 1. So and needs to know where is it true for both. So it's true for both between negative 2 and 3. We're going to have a closed circle because we are going to include the border, because that's where it's true for blue and true for green, and that would be the answer. And then what I've been doing is also writing a sentence for this. Negative 2 is less than or equal to x, which is less than or equal to 3. It's not asked, but I don't think it says. No, it doesn't say it, but it's good practice, and I'm staying consistent with it. So let's write the statements. 2x plus 1 is greater than or equal to 1, so that's an or statement. 2x plus 1 is less than or equal to negative 1. So the initial one tells me whether it's an or, not these. This just tells me I always got to write the greater than and less than. So minus 1, 2x is greater than or equal to 0, divide by 2. X is greater than or equal to 0. Minus 1, 2x is less than or equal to negative 2. Divide by 2. X is less than or equal to negative 1. So let's move these down a little bit so I can sketch. We have negative 1. We have 0. We'll do this in green, that in blue. Green, x is greater than 0. Closed circle going this way. Let's see, that's an or also, so that's important to remember. Always remember, whether you're doing or and, x is less than or equal to negative 1. That's a closed circle going in this direction. So it is going to be a union. So we get wings most of the time on unions. So that's the solution. And if we had to write it as an inequality or a statement, we would write x is less than or equal to negative 1, or x is greater than or equal to 0 would be the proper way to write that solution. 2x minus 3 is less than, so less than is and. 2x minus 3 is greater than negative 7. Add 3. 2x is less than 10, divide by 2. X is less than 5. Add 3, 2x is greater than negative 4, divide by 2, x is greater than negative 2. This is an and. My sketch, negative 2, 0, 5, green, blue, green. X is less than 5, open circle. X is greater than negative 2. That's good. So we get this as our final answer. It's an intersection because it's and. So my final answer would be this. I would always write it as a separate graph. So I would never submit this as my answer. Don't expect the teacher to know that you know that the intersection is only this part. This is all, that doesn't tell me anything. So leaving it in that manner is not going to be accepted as a correct answer. So be careful. Know that you're going to have to consolidate it as 1. That's greater than, so that's or. 2n minus 1 is less than or equal to negative 3. Add 1. 2n is greater than or equal to 4. Divide by 2. N is greater than or equal to 2. Add 1. 2n is less than or equal to negative 2. Divide by 2. N is less than or equal to negative 1. That's an or. Ran out of space. Let's sketch it. Negative 1, 0, 2, green, blue, go back to green, and is greater than or equal to 2. That's a closed circle going greater than. Negative 1, closed circle going down. So the union of that looks like this. With no colors, we just want the solution. And that looks like x is less than or equal to negative 1 or x is greater than or equal to 2. For x minus 13 is greater than 7, greater or for x minus 13 is less than negative 7. Add 13. For x is greater than 20, divide by 4. X is greater than 5. Add 13, add 13. For x is less than, that's 6. Positive 6 divided by 4. We get x is less than 3 halves. So there we have to reduce. There we must. Every math teacher will tell you that all fractions have to be reduced. So we're dealing with ors. Yep, this is an or. That's 0. That's 3 halves. This is 5. Green, blue. X is greater than 5. Open circle. X is less than 3 halves. Open circle. So, whoops. 0 up. Take your time. Do it right. We can even do 1 1/2 if you want. If you want to make it mixed numbers, I don't care. I understand where 3 halves is. So I would be okay if a student wrote 3 halves. So x is less than 3 halves or x is greater than 5. 6 minus 3k is greater than or equal to 9 or 6 minus 3k is less than or equal to negative 9. Let's minus 6. Negative 3k is greater than or equal to 3. divide by -3. Notice we're dividing both sides by a negative, so I must flip my inequality sign. -6 minus 6, -3k is less than or equal to -15. Divide by -3. We are dividing both sides by a negative, so we're going to flip the inequality sign. This is still an OR. Sketching. -1, 0, 5. That in green, that in blue. Green looks like k is less than or equal to 1, closed circle going this way. K is greater than or equal to 5, closed circle going this way. Still no special tricky problems, nothing that is a 1% problem. These are your prototypical problems that we should be very easy to graph and to write. How many more we got? Whoa, I thought I only had one or two. I definitely, we only have three more. 4 minus 2k is less than or equal to 4. Less than is an and. 4 minus 2k is greater than or equal to -4. -4, -2k. Ooh, I like this problem. A lot of students will just go to 0. They'll go, oh, k is less than or equal to 0. No, we have to still divide. And that negative, this, okay, here we go. I just asked for, I asked for a tricky one and I got it. Ask and you shall receive. So this is a really important problem to focus on. A lot of students will just jump to, well, divide by 2, it's still going to be 0. But that dividing by -2 is going to flip that inequality sign. So very important. -4, it doesn't happen on this side because you get -8. But we still are going to flip the inequality, but we'll have a value. K is less than or equal to 4. So let's sketch 0, 4. Let's move this out of the way a little bit. We'll do this in green, this in blue. K is greater than or equal to 0. K is less than or equal to 4. Boo. I wanted something cool. Something a little bit different. Did I do that correct? Yeah. Okay. It's still a pretty plain Jane problem. Intersection, because it's and. That would be our answer. And the compound sentence would be 0 is less than or equal to x, which is less than or equal to 4. Okay, ho-hum. Fractions, you think fractions make it harder? No. X over 2 minus 1 is greater than or equal to 3. Greater is or. X over 2 minus 1 is less than or equal to -3. Let's add 1. We get x over 2 is greater than or equal to 4. Reciprocal of dividing by 2, or the inverse of dividing by 2 is multiplying by 2. We get x is greater than or equal to 8. Add 1, add 1. X over 2 is less than or equal to -2. Inverse of dividing by 2 is multiplying by 2. X is less than or equal to -4. That's an OR. We're going to move that down a little bit so we can sketch. We have -4. We have my 0 and 8. Whoop, not yellow. We'll do that green, that in blue. You're my boy, blue. Green, x is greater than or equal to 8. X is less than or equal to -4. Okay, so easy. These aren't even hard. It's just being consistent, not making silly mistakes. X is less than or equal to -4. I know I'm not doing a very good job. I'm rushing that. Greater than or equal to 8. We'll run it. We'll rewrite it. We'll take the time. All right, last one. Are you going to get tricky? Nope. I don't think you are. Negative x over 3 minus 2 is less than or equal to 2. Less than is and. X over 3 minus 2 is greater than or equal to negative 2. Add 2. Add 2. X over 3 is less than or equal to 4 times 3 times 3. X is less than or equal to 12. And add 2. Add 2. X over 3 is greater than or equal to 0, multiplied by 3. Don't flip the inequality sign. So we get that? Nope. Very typical solution. And look, you don't have to do the sketch. That is one thing. If you understand how this is going to come out, because you've sketched so many and you understand what it looks like, then don't sketch. Just give me the final answer. I'm okay with that. I'd be okay and accepting that. Close circle. Close circle. And yes, you saw that the intersection was going to be 0 to 12 because it was an and you could see that. So 0 is greater than or equal to x, which is less than or equal to 12. And there you have it. Those are all the problems. That seems really similar to, and really expand too greatly on 10.6 to 10.5. So it's still good practice. I mean, it's still things that you should be proficient at, and the only way you become proficient, I'll try that one more time. The only way you become proficient is through practice. Good luck.